Hello everyone, my name is Alejandro Ojeda, and today I'm going to talk to you about Lab 5 for Physics 2212. So, for this lab, the purpose was for us to use Faraday's law to collect data of a magnet falling through a conductive tube of aluminum foil. And the materials and formulas for that I used for this were a smartphone, in this case my iPhone, an aluminum foil to make the tube, a bar magnet that was provided, magnetometer, which is found in the iPhone. Then for the formulas, I used the Biot-Savart law, which is the magnetic field formula. I also used Ohm's law, which is voltage is equal to current times resistance. Then, to make sure, uh, voltage here will be the absolute value of EMF, and to calculate EMF will be to get the derivative of the magnetic flux, when the flux will be the integral of the magnetic field times the number of loops times the derivative of the area. And this area, the system was the bar magnet, and the surrounding was the aluminum foil. Oh, and also important to mention that to put gravity, like the force of gravity, also in this. So, this experiment, I registered that the aluminum foil was 0.27 meters long, about the width of about 0.002 meters. The inner radius was about 0.015 meters. And I had, and then, like the instruction said, I did the experiment 5 times, testing the times, and with the observation, I calculated that it took around 1.75 seconds as the average time taken from going from the top to the bottom. And here on the photos are like what were the results that I got computationally. In this case, will be 1.706. So about 0.04 second difference. Here is the code. Just for y'all to see. This is not as important as the next ones, since this is like where most of like it matters for the answer. Since this is mostly what I had to change, since it has most of the steps. But in addition, I might have done some errors. I might have collected the data incorrectly with the magnetometer. I am only human, and I can't really calculate sometimes the falling of the bar magnet and match the time at the same time, so there might be some timing issue. And the MU that was used in the computation for the code that was supposed to be gotten from lab 3 might be wrong. Because, well, for me, it was 1.2. So we might have different MUs. And finally, the what ifs. If the resistivity of the conductor were reduced as close to zero, the magnet would take longer to reach to the other end. It's because the magnetic force would increase and also the induced current, meaning because it's going force of gravity minus the force of the magnetic force. And if the magnetic force gets bigger, that means that there's more force against the bar magnet, making it go slower. Now, if the holes or slots were caught into the tube, the opposite would happen, since now the magnetic force would be less. Therefore, the force of gravity would have more effect on the bar magnet and make it go faster. Thank you so much.